Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Orthogonal Parity Line Arrows 2 by PageDo. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have digits orthogonally connected by a double red parity line. One digit is odd and the other digit is even. So what does it mean by orthogonally connected? It just means that they share an edge. So basically, any digits that share an edge through a double parity line, which is like this, one of them must be odd, the other must be even. Okay. Digits along gray arrow lines sum to the number in the circled cell. Digits may repeat along arrows if allowed by other rules. So for example, if this were, say, 2 and 2, this would have to be a 4, because these two digits along the arrow must sum up to what the digit in the circle is. And that's an example of how arrows work. Digits in cells joined by an X sum to 10, digits in cells joined by a V sum to 5, and digits in cells joined by a white dot are consecutive, and not all X's, V's, or dots are necessarily given. So this is typical XV, and then white Kropke dots. So for example, we're going to have them all be 3. So if this is 3, this is 3, and this is 3. No, that can't be 3. But say this was 3. Then this would have to be 2, because these two digits must add up to 5, because there's a V in between them. This must be 7, because these two digits must add up to 10. And this must be 2 or 4, because these digits must be consecutive. And this is 10, because it has an X in between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we have something with a V is the sum of the other two digits. This cannot be 2 or 1, so this must be 3 or 4 here. But this is the opposite of both of these cells. Right? The opposite parity, shall I say. I'm sorry. So it's the opposite parity of both of these cells. So these cells must be the same parity. Well, if you have two odds added together, you'll get an even digit. If you have two evens added together, you'll get an even digit. So this must be an even digit, which makes this a 4. This is 1, and this is 3 to add up to 4. So since these are both odd, this must be even here. So we have, this is 2 or 6. Or cannot be 8, because 8 would have to add up with 1 to add up to, at minimum, 9. You can't have 6 either. 6... Well, you could have 6. Okay, wait. This is opposite parity of this, which must be the same parity as this. So these two are the same parity. Oh, well, that's given, because this is an even digit. So this is an even digit. These are odd. This must be even. It could be 2 or 6 here. These are differing parities. So that means one's even, one's odd, which means this is an odd digit, which means these are even digits. Since this is an even, this is a sum of an even and an odd digit. To form an odd digit, this must be odd. These are different parities. These two cells are the different parity than this cell, but they're the same as each other. So if it's 2 odds, that forms an even. If it's 2 evens, that forms an even. So this is even, which means both of these are odd. This is consecutive with an odd, so this must be even. Because every consecutive, like, obviously every odd digit cannot be consecutive with another odd digit, and every even digit can't be consecutive with another even digit. Okay, yeah, so this forms a pair of opposite digits. This is a pair of opposite digits. This is a pair of opposite digits, which means this is odd, because we have all 4 evens accounted for in these cells. Same with here. These are opposite, these are opposite, these are opposite, these are opposite. That's 4 evens accounted for, so this is odd. Well, we have 2 opposites here and opposites there. So that's 2 odds. That means these are 5 odds in this box here. So this must be even. Since this is even, this must be odd, which makes this even. That means this is odd to add up to 5. So these are 3 sets that are evenly split. So there's 2 odds and 1 even here. Okay, that's not helpful. Okay. This is opposite sets. These are opposite sets. These are opposite sets. Therefore, for this to be opposite of these two, these are the same set. If they were both even, you'd have 5 evens in column 7, which is not allowed. So these are odd, which makes this even, which makes this odd. Odd is consecutive with even, even's consecutive with odd, odd's consecutive with even. That makes this even, this is odd. Okay. Odd must have an even and an odd. This is even, which forces this to be odd, which forces this to be even, and this to be even. These are the same parity. Whenever you have a 10, it's either 1, 9, 2, 8, 3, 7, and 4, 6. Notice they're all the same parity. So we're going to make that as a pink. So these are the same parity. We're going to make that orange then. So these are opposite parities here. Therefore, this is pink, this is orange. Okay. Does that tell us anything? I'm not really sure. These are opposite parities. So we have 1 blue and 1 red here, which forces this to be blue. Red plus blue, so odd and even, makes an odd digit. So this is odd, which means in this lower right-hand box, one of these is red. We have 4 other reds, so that means this can't be red. This is even. Well, to get an even from an odd digit, and it must have another odd digit. So this is odd, this is even. This cannot be 1 and 4. Sorry, this can't be 2 and 3 because of a 3 in the row. So this must be a 1, 4 pair here. Okay. That means we have 1 and 4 here also in row 4, because 1, 4 can't be here in this box here because of the 1, 4 pair in the box, and this can't be 1 or 4 because of the 1 and 4 in that box. Where do we go to next? These are opposite sets. That gives us 4 odds and 3 evens in row 3. So this must be opposite sets too. Okay. These are the same set as each other. Oh, we have 4 evens in column 6, which eliminates evens in the rest of the column. So this cannot be 4. This isn't odd. These are odd. With this is since this is odd, that makes this even, which makes this odd. This has to be 2 or 4 here, which must add up to 5 with 1 or 3. Okay. This digit is less than 3 other digits, so it cannot be 7 or 9. This is 1, 3, or 5. This could be 4, 6, or 8 as an even digit that sums up with 2 odd digits. This must be 1 odd and 1 even. We're not sure which is which. Okay. What else do we have? This has to be at least 2 and 5, so this is 7, 8, or 9 here. Okay. These digits are consecutive. Oh, okay, that's interesting. So you cannot have 1, 2, 3, or 4 here. So you have, this is 5, 7, or 9. Cannot be 9 because 2 digits in the same. Okay, so this can't be 1. So this is at minimum 3. Well, okay, so then this has to, this is at minimum 5. This is at minimum 1. So since these are all minimums of 1, 3, and 5, that adds up to 9, which is the maximum this could be. So this has to be 5, 3, and 1. So 5, 3, and 1, which makes this 4. That means this is 9. So pinks are red. Oranges are blue. Okay, so then this makes this 8. So this is 8. 5 is only consecutive with 6 because 4 can't be there. So this is 6, which makes this 2. That's 2 and 6 adding up to 8. 3 is consecutive with 2 out of these. So this is 2. This is odd, which makes these even, which makes this odd. Well, this last even here is an 8, so it's 1 and 7 adding up to 8. Therefore, this is 9. 9 and 1 add up to 10, so 1 cannot be here. To add up to 8, that's interesting. 3 is consecutive with 2 or 4. So this is 3 or 5 here. Because that's consecutive with 2 or 4. 4 eliminates 4 here, so this is 6 or 8. We have 7 and 9 remaining. Ooh, that's problematic. 7 and... Oh, this is not 9. That's the reason why. Okay. That's 8. This is 7. So this is 5. There we go. So we're missing 7 and 9 in row 5. 7 can't be here because 7 in the box, so that's 9. This is 7. This is 2 or 4 still, again, next to 3 or 5. This can't be 4. We have 2 and 6 here. And this has to be 3. So to add, this can't be 4. It could be 6 or 8. So this is 3 or 5 here. Cannot be 5. So this is 3, which is consecutive with 2 out of 2 or 6. So that's 2. This is 6, and this is 6. That eliminates 6 here. So this is 8. These digits are consecutive, but you cannot have a 3-5 pair because this can't be 3 and 5 to add up to 8 because that would eliminate all possibilities for this cell. So this is 1, this is 7. 7's only consecutive with 6 because 8's already taken. So this is 6. This 3 eliminates 3 here, so this is 1 and 4. 1 can no longer be here. This is 9 and 1 to add up to 10. So 1 can't be here either, so this is 1. The remaining digits in the central box are 4 and 7. 4 here eliminates 4 here. So this is 2, which is only consecutive with 3 out of 3 or 5. So this must be 1 and 2 adding up to 3 here. This has to be 5 or 9. This even digit can only be 4, so this is 1 and 4 adding up to 5, which makes this 9. This cannot be 1, 8, 2, 7. It cannot be 3, 6 because of the 3, 6 pair here. So this must be 4 and 5 to add up to 9. 4. This is the last odd digit. It's 9, which makes that 5. This has to be 1 and 8, so this is 8. That's 1 to add up to 9. Last digit in column 8 is a 2. That leaves this as 4 and 7. So 4 is here and 7's here. Okay, this adds up to 9. This is at minimum of 4. And it can't be 6. It can't be 8. Can't be 2. So this has to be a 4. This is at 4 eliminates 4 here. So that's 7, which makes that 4. So this is odd. This is even, which makes this odd. And this is at minimum 5. It can't be 9, obviously, here, so this has to be a 5. Which means these add up to 3. And 1 can't be here, so this must be 1 here, and this must be 2. So this is 2. This is even, which makes this odd. This is odd, which makes this even, and that's a 6. We have 4 evens in column 4, which eliminates evens in the rest of the column. So these are odd. This is odd. You can't have 7 here because 4 and 7 already added to 11. So this has to be 3. And that leaves this as a 2. So this is even. This is even. This is even. We have 4 evens now in column 3, which means this has to be odd. So you have odd and odd, which must equal an even. We have 4 evens in row 8, which eliminates evens in the rest of the rows, so these are odd. This has to be 5 or 7, cannot be 5 because of 5 in the box, so this is 7, this is 5. This can't be 1, 7, or 5 here. Can't be 9 because 1 and 9 add up to 10, so this must be 3. So this is 3, which forces this to be 9. This is 8. 1 and 3 add up to 4. This can't be 9. It can't be 7. So this is 6 or 8 here, guaranteed. Yeah, we have 5. Okay, this is odd, so this must be 9. That leaves evens as the remaining digits. So since these are even, this must be even here to add up to an even digit. Even plus odd adds up to an odd digit. That means we have 5 odds in row 3, which leaves this as even. And we have 4 evens in this upper left-hand box, so this must be odd. The last odd in row 3 is a 7. The last even in row 3 is an 8, which makes this 6, which makes this 8. And this must be odd because we have 4 evens in row 2. This is 2 to add up to 4 to add up with 4 to add up to 6. 2 and 7 add up to 9. This is 5. Remaining digits in row 4 are 8 and 9. 8 can't be here because of 8 in the column, so this is 9. This is 8. This is even. And rest of column 1 is all odd because we have 4 evens. This can't be 2, 4, or 6. This must be 8. Looking for 7 and 9 remaining in row 8. This can't be 7 because of 7 in the column, so this is 9. This is 7. We have 1 and 5 remaining in column 1. This can't be 1 because of 1 in the row, so this is 5 and 1. Odd digits here. This is 7. This has to be 3. We have 6 and 9 remaining in column 5. This can't be 9 because of 9 in the row, so this is 6. This is 9, which leaves this as a 6 and this as a 3. And that's all done. I don't know. The logic here felt a little bit more difficult than very easy, but obviously it wasn't that bad. Huh. Yeah, I mean, you'll often run into these types of puzzles, though, where you have to count the number of odds and even digits in a row or in a column, because it's that's one way that you can solve a lot of these puzzles very well, and it's not that restrictive either, right? So therefore, there's a lot of space allowed for setters to set some interesting puzzles. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.